In the first day of the session, we will understand about what is artificial intelligence. So, what do you think like artificial intelligence is? Artificial intelligence is kind of like a combination of many things being added together. Like you may have the different kind of capabilities being added to it. Like you have when you had seen over the uh, normal thing, right, where you will have a Venn diagram which should be defining like this is an AI, and we will have the machine learning being part of it as the next, and then we will have deep learning, and then we'll have the Gen AI being added. So we'll have everything being. Machine learning plays the major. Machine learning is also a subset of the AI, and inside that we have deep learning, and then we have inside that to be of Gen AI is all something that we might have saw until today, right? Like out of that, we want to understand for what is a machine learning to be kind of like when whenever you have the machine learning, then whenever you have a artificial intelligence, then it doesn't mean that you want to be a ML engineer, and um, ML engineer's job is to kind of like have how does that happen with models, and then how does that work with the different functions which are happening and all those things. But that's not something that what we want for now. All we want is like we want to understand what is artificial intelligence, and what is the machine learning concept that what we have. And if we have the machine learning concept, then what we are expecting out of it is something that we will see. And for that, we'll be having the information extraction. Parent will have the information being, this is something that your OCR and other things act like the optical character recognition. So we'll be having that OCR being added. Like you may extract it from PDF or Word, or it can be of anything that what you are wanting to do. All that will be done with the help of like information extraction. When it comes for computer vision, then it's something like when I'm just taking an example, when you are going with the, when you want um, some kind of like a thing where you want to go with, when you are going and when you want to be detected by yourself that this is you, and the attendance has to be marked by yourself, like has to be marked, or the doors has to be opened, then all those kind of things can be done with the help of the computer vision. And when it comes for natural language, it is something like where you will be applying the natural language, where you will have the language which will be useful for your own data that what you wanted to do, and from there you will have the information being extracted for the same. And then if at all, regularly we have this kind of like chatbot and other things, right? Like, how does your chatbot work? It will be with the natural language which is happening. Like, it gets converted into the user language, and then from there, it will have the language being used for yourself, and from there, it will give you the response for that. So, this is how it will make your natural language work for yourself. And will understand about like what is agents and automation. So agents and automations are something like whenever you want to have something like one which will have the autonomous way, then you will be having the um, responses based on that reply. And like it will be doing from end to end on that particular task, and it will be giving you the response of what it is, and you will also get the response of how it is working. So inside the agent you will have the context being set, not just the one that what you want to work with along with the natural language. Like if it's just a chatbot, then what will you do? You will convert that into a natural language and you will have the things being generated. But in agent, you will set the context of what it has to happen with instruction and all those things. And from there, it will be working based on the part that what it want to happen with. And what it happens in automation. Automation is kind of like a process you will be having the where you will be having the automation which can perform, like say in case you have a repetitive task, and that repetitive task will have various things being added, then all that can be done with the help of like automation that what you have. So that becomes the automation what you want to perform with. And when it comes for generative AI, it's something like when you want to apply some kind of like generative AI concepts to it, then your artificial intelligence will support it as well. Like when you want to add the um, transformer kind of rules, or when you want the chat GPT to be added, like the GPT models which can be deployed. And then if you want the embedding models to be done or image to be generated, then all that which can happen with the help of the generative AI. And moving forward, right, we will understand what is exactly of each thing, and will be having a better understanding of each of it. So before we move to next part, we'll try to understand like what is LLM and what is agent. So LLM are something like which can just think, and agent are something like which can think, which can decide, sorry, which can decide and which can act based on the one that what you have. So it will be like having the think, decide, and act on the one that whatever you wanted to have with. Now, let's come for what is AI agent and agentic AI. AI agent, agentic AI. So, when it comes for agentic AI, right, when you have the multiple AI agents being added, or when you have the orchestration being defined for what it has to do with next agent that what it want to flow with, or whenever it has the multiple tools being added, or what what next that what it has to perform with, when it has memory, when it has the different kind of detail that what it want to do, then the agentic AI will be playing a major role. And when it comes for AI agent, then it's something like it has instructions being passed on what it want to act with, and then it has the tools, it has the uh, user prompt, system prompt, different agent messages that what it has. So all the one that what we have can be combined with the help of like AI agent. Like you will be having the LLM as well as some kind of like decision, and then you will be adding all these ones together, and you will make it form the agent. And what this agent exactly does is it will be having the instruction tools, user, and all the different one that what it has, and it will be giving you the response on that format. And now what we want to do is like we'll be having the agentic AI to be kind of like when multiple agents work together, right? Like you have agent one, agent two, agent three, that could be of anything. And when this agent want to get passed to agent two, or when this want to pass with agent three, then how will it do? It will be like passing the one memory that what it has, and it will be collaborating with each other, like it will be communicating with each other, then it will not know what it has to happen with. So all that with the way of communication and all the one that what it happens, right? Like unless and until it doesn't know of how it want to communicate, whether the memory has to be shared, or whether the API has to be shared, or whether it has to have the tools that what it want to act has to be done. So all these ones can be combined, and all the one that what whenever the AI agent want to get combined with the second agent, then it will be acting on that way. And this is kind of like happening happening in the AI agent that what we have now. I mean, if you don't understand anything now, right? Like we'll be covering each of it on a deeper way, and we'll be kind of like having the AI agent being added for you, and we'll have the AI agent being like this is whole set of the agentic AI training that what we are about to see. So we'll be right from starting having the LLM to the agent of how does it work. We'll be covering all of those ones. So please make sure that we'll be having everything being covered, and don't stress yourself at this moment like if you don't understand anything with that. And for few of you, you might have already known some of these topics. However, as part of the prerequisite, we'll also be covering the critical agent foundation, so that you understand the one that what advanced topics are being covered properly. Now, let's understand like how does the language reasoning system works. The reasoning system works in a way like whenever you are giving in the generative AI model alone, right? So it will you will be getting the input, and then you will be getting the output. If it's a dog kind of image that what you want, and if that needs to be added, then you will be giving in the input, and from there you will get the output. And if that does not work, then your Gen AI orchestration will be playing a major role, where you will be having the various ways like how it want to interact with, and how it want to give the output. It knows where it flows from, and it knows where it has to get the base of how it want to act with, and all the ones that what it want to do is all that it will be having an assumption of. So that will be kind of like having as an example of what it does. And when it comes for sequential modeling, why do we call it as sequential modeling? Is like modalities are something that what your input can be found of. And for that input, right, it can be of text, or it can be of audio, or it can be of image. 3D or even your DNA, protein, molecule, or animation, all that which can be added. And you can get the output in different formats, like it can be of animation, molecule, or even the DNA. 3D image or audio, that could be of anything that what you want to do on. So all that what you are wanting is, if you give the text and if you expect that in the format of if you give the text and if you expect it in the format of audio, then your whisper model will be one which will play a major role, if you remember, right? And if you give the audio and if you expect the text, then that's again possible with whisper model. And if you give the image and expect it in image format, or if you, it can be a re-imaging basically, or it can be a different thing that what you want to do, like addition or deletion inside the image, or it can be a image and you want to extract the text out of it, or it can be an image and you want to do a animation with that part, or it can be a video and you have to extract the audio out of it. So that could be of anything that what you want to process with the help of the sequential model. It's just like you have a model, and from that model you will be giving an input, and that input can be of anything, and you can have the output which could be of anything as well. Like you will have the base of defining each of it. Now let's see what are some kind of like prerequisite which are being available for it. So for that, we'll be having the ones like you will have the you will need the Python knowledge as a basic one, and then basics of NumPy, basics of Keras and PyTorch. And even if you don't know at this moment, then fine, we will be handling it anyway. Like this whole sort of session will go like this, like we'll be having the lab part being defined for you on each step what we are doing. So don't worry about that right now. And you have to know about the JSON L or JSON XML of how does it work. So if you understand that better, it would be easier for you to grasp the concepts even more clear. So that's why we are setting some kind of like prerequisite. And for the prerequisite to be happening, right, you also have to understand what it exactly happens with the deep learning model. With the deep learning model, what exactly is a deep learning model? First, we'll understand that format. Will be, I mean, first is something like whenever a deep learning model, how does a deep learning model work? It works with different neural that what it has, right? So if it's a different neural, then neural network that what it want to pass with, it will be having a raw data and it will become a trained model that what it want to process with. And whenever you are giving a raw data, then how it will happen is like you will be giving it a training data and your model gets added for it. And how does your training data and model will be understanding? Now let's take a simple example two of a cat and dog, and we'll try to understand from that concept of how does the how does the cat and dog are being kind of like separated and classified as part of the deep learning. Now, let me ask you a simple question. Like, if you go straightly to a model and ask it for a image and identify whether it's a cat or dog, will the model know that it's a cat or dog at first without you being trained on it? No, right? Even at first, when we were child, we were given image that this is a cat and this is dog, and then when we started seeing them on streets, we started knowing that okay, these are the functionalities and these are something like that. what we want to understand is all something that we got to learn day by day, right? And that's the way a baby will also be learning. And consider the deep learning to be of like a baby, where you will have to give training on that, and all that training that what you give will be in different neurals that what it has, and to identify whether it's a cat or dog, and it's all based on the probabilities that what it want to do with. At first, it does not know what is a cat or what is a dog, and for that, it has to pass with different layers. It has two ears, it has eyes similar, even it has the eyes to be like similar, right? So we'll have the tail which is kind of like similar, fur will be different, and this part will be different for it, and the way that what what cat has will be, what cat has as some mouth will be different. So we'll be checking on each of the one that what it has, and we'll be having all those ones in kind of like, I mean, your whiskers will kind of like differ, right? So you will have the mouth being differed in a way of the dog. So you will be defining all these ones, and from there, it will actually differentiate from the dog and cat. And now, when you give the convolution neural network, like it passes to a different layers that what it has. Like it will be of sparse and it will be of dense that what it has. Like sparse is something that which will make the understanding about the cat and dog together. Now we saw some kind of like similarities between the cat and dog, right? And now we'll understand what's about the dense. Like dense is something that the task ahead. So your feature extractors are kind of like the features that can differentiate between the cat and dog. Like you will be having eyes, whiskers, nose, and then your mouth, tail, fur, and all those ones that what you have is all coming under the feature. Now, task ahead. Task ahead is something that what you have for cat. Like you have to find out the cat is something that you want to do. So it will be having the task ahead as you want to find out the cat. Will be having whether it is kind of like a probability being assigned to it, and that will decide whether it's a cat or dog or bird, and from that probability it will be giving you the response on that format. It's something like you will have the probabilities being applied for each of it with some kind of like formula that what's been there. And if you want to understand the entire formula, that's something that the machine learning engineer will go ahead with. And we just want to understand something that it will be happening in this way. And that's enough for an AI engineer to work with. We don't have to be an expert of each of those things to be having on what exactly an machine learning engineer will be knowing on with. And numerals and the formulas all will be taken care by machine learning engineer, where his own task of working with the data and other things are with the one of finding the differentiation or with the formulas that what all he can apply with and other things. And when it goes for the dense one, right, you will be having first is like you will have the image being identified, and from there you will have the clarity of what it you want to achieve will be applied over here. And then at last, with the help of the formulas that what you have, you will be applying the concepts of concepts of the uh, loss function and other things being applied, and from there you will find out whether it's a cat or dog or bird. And for whatever the probability which is of high, you will find out that it's of that variety. And you will be for that, right? You will have the loss function being applied. Loss function is one of the commonly applied function when you go for a rag, or when you go for some kind of like vectorization that what you want to perform. All the loss functions will be playing a major role. So loss function, how does that work? It's kind of like it will be normalizing. First, it will try to normalize the one that what you have, and say in case if you have a vector of array where you have 0.93 and point 6 or something of that sort. And what's a arrays concept? It should be something like always one, right? And how do you normalize this array? Then you will be applying some kind of like square root, or you will have some kind of like formulas which will happen when you want to divide, or when you want to apply square roots. And unless and until it turns into one, you will be normalizing the the factors of the loss function, right? Like that becomes basically the loss function that what you want to do. Unless and until it is kind of like cat, say you have identified it as cat of 80%. Unless and until the cat is kind of like 100%, you will be applying some loss function, and that loss function will make sure that it's just a cat and it's not a dog. So, to make that surety come, you will make that work, and you will be applying functions for the same, and will be having the loss functions and other things being added. And from there, you will get the output on. Now we understood like what is loss function, what is that we are doing, and other things. Before we go to anything that what we have, let me also show you simple examples like how does the just give me a minute so that I will get back over here. Now we'll understand something like how does your AI agents work, and how does your RAG work, or you have different things. If you don't understand RAG at this moment, then it's totally fine. And if you are new for it as well, we will know what is it and what is all that what we have. But how does generally a agentic AI work is like, we have a concept called as tokenization, where each one that what you apply with, when you even take an example of chat gpt, right? If you We now have pro and we are using it for free, but earlier when you have not paid for the pro version, then you will be stated that your quota has been exceeded, and you have to wait until this moment. If you had observed it, you whenever you are trying to get the output too much of it, or whenever you are having some kind of like conversation being added, something like that, right? How does that happen? It's all because of the token limitization that what it has. Like when the token is kind of like exhausted, then you will get that like your everything on the model will be working based on the token. Either it could be of input token, and either that could be of output token that what you have, and that gets passed on to the model, and the model will actually have been defined of how much token that what it want to execute, right? So we know like this token plays a major role. For that, we have to understand what exactly the token is, right? I will show you an example where we'll be having the tokenizer, which is kind of like available by the OpenAI as such. Like whenever you want to find out the tokens which are being part of whatever you had developed with, then you will be having the tokenizer being added to it. Like a tokenizer will be kind of like the one which is kind of like free, which was given by the OpenAI as such, and you can check out what are the different tokens which can be added as part of your input, and how much token you are consuming as the model grows on. So we'll be showing an example. When you give the example over here, right? Like see, for different models, your token differs. First, let's observe that for different models, for the same input that what you have, your token differs. How exactly it is happening? It's because of the word mapping or the character mapping that what you have over here. Your character still be the same, but you have the tokens, which is like 53 tokens at the start. And when it goes for GPT-4, it's 57. When it goes for GPT-3, it's 64. The same example that what we have, but when we use the GPT-4, then that becomes 57. When you go ahead with 5.5 versions that what you have, then that becomes 53. How does that happen? It is all because like even you give the space over here. When you remove the space, how does that happen? Your token remains same. But if you observe here, your space that what you have given is also being counted as one character. And how does this token work? It's kind of like translates roughly 3 by 4th word. So 1000 tokens equal to 75 words is something that what we can understand with. You have the thumb rule of it where you will be having approximate of 4 characters. If you add 4 different spaces over here, what will happen? Let's see. Now, can you see the difference? We added 4 spaces in between, and the token got increased by 1. So if you should be mindful of how much token that what you are giving it as well. If you are giving it space and if you are consuming it, then what you want to pass as expected will be kind of like not getting passed to it. Like you may want to pass it something to be like this format, and you may get something from your model to be in a various format, and you will be passing the same directly to a agent model, right? And how, if that exactly can be worked on, or if that has too many spaces in it, then what will happen? What you want at the start or what you want at the end will be chucked off, and you will not be knowing what you give over here. Say, in case if your model is just limited to 50 token, then your 5 token at the end will chuck off. You will not be able to give that to the model. What you want is not getting passed to the model just because you are adding too many spaces. And if it goes like 54 model or 53 model, then you are limiting the size when it's just been set to 50. then you are limiting the size to be of just like your 3 token is alone getting different, which is just like 12 words getting different. Now, even when you adjust that, you may have the difference of like your 50 token can be passed on to it. Now that became 2 now. So it's just 2 token that what you try to consume over there. And that one hand that what we had 4 token of it, and that went off, and that immediately came down to 40. So that's where we will be kind of like seeing what exactly gets passed in as part of the input, and how we can limit it, and how we can get the output on. This is a perfect example, and you can plan your token on which model and how do you use for free with the help of this particular OpenAI platform. I mean, this is being given by you as part of the OpenAI platform, and you can go ahead and use it. Now, let's understand the same. How does that happen? Now, you have a sequence of letters, and inside the tokenization, what happens? You are splitting that up into the different ones, like hello, how is it going? And as we just now saw, your 4 letters is kind of like considered as one token. So even when you add exclamation or anything, your 4 letter will get considered to be your token that what you have. Your token can be of ordered, your token can be of in the format of sequence of classes that what it exactly wants with. Let's see like the base formulation between having the hello, how is it going, is like you will be having everything being split. And how does that exactly happen is you will have the sequence prediction first, which is like 90% positive, 10% negative. And then you will be applying the pre-token prediction. And then you will be applying the forecasting prediction. So, have you ever observed when you go in the edge and when you start typing in, it will be giving you suggestions? And or if you start typing something to a model as just like a example, and when it starts giving you the response of what exactly it knows, and it assumes what you are, where you are trying to go. Have you ever felt that? How does that happen? It happens with the way of sequence prediction, where the 90% positive, 10% negative, and other things happen. And we have things called pre-token prediction. Before even your token is getting generated, you will be predicting of what would be the output. When you just see hello alone, you will be kind of like, and when you see how is it going, you will now get the answer of what exactly it ought to go with. Like, I'm doing great, it's going great. Is let's see an example for the same. So pre-process is like where you will be converting the data that what you have to tensors, where this happens with the formula of auto tokenizer, which will be helping you in tokenizing the concepts which are being there, and it will be giving you the output on the same. Now that the pre-process has happened, and then it will be moving to the output. Now you may wonder what is a tensor over here. Tensor are something like when you want to add the way of how to share and work with the data in multiple dimensions, then that becomes the tensor. Like you will have the way of single number being added, or single dimension that can be acted with, and all the one that what you have over there is like the tensor. And your pipeline component will be in the format like it first gets passed into the, I mean, the input that what you give will be passed first into the tensor, and that tensor will be converting, I mean, will be converting your tokens, and that tokens is kind of like auto tokenized, and that auto tokenized will be moving to the forward one, where you might have got the tensor now, right? And that tensor will get converted into the model dot forward. And once you get that model dot forward, you will arrange them into the dictionary for post process. You now you understand the flow. First is you are having the pre-process, and pre-process is getting into the forward, and from that forward you are passing it to the post-process. So inside the forward, you will be applying the auto model for task, which is you now have the tokenizer, and that tokenizer will arrange them into the dictionary, and that dictionary is called as the auto model for, and you will be using that for those things. And once you have the data from all the one, you will once you have the data from all the one, you will be converting that into a intuitive output per task spectators that what you want to ask with. That's where your pipeline is about to happen. When you just give it something to be like, it's so, and that could be of, it's so fun, it's so cloudy outside, it's so something that which happens next can be predicted, right? Like that prediction of what we want to get as an output is something that the whole pipeline with the tensor is kind of like happening over here. Now let's see an example of how does that work. It's so fluffy, I'm going to die. How the we have three different function: pre-process, forward, post-process. The same one is being added: pre-process, model, post-function. Pre-process is something that which happens over here. Post-process is something that which happens. Forward is the model function that what we had given. So model dot forward. So we'll be having the pre-process, forward, and the post-process that what we have. We'll be applying each of it a formula of what we want, like pre-process, model, post-process, and we'll be giving it a response. Like whenever it converts into the preparation function, hi, it's so fluffy, I'm going to die. It's something that you are giving it. Then what it does exactly is when you see the output, right? Until here, this is the first preparation function that what it had did. So you have a tensor, and that tensor defines the dimension of 0 to d. You have different things being added, like you have the 151, 152, 153. Each one of it is being given a dimension for it. And then you are getting in the token ID types, and that is again getting converted into different dimensions over there. Attention mask is something that which is getting converted. You can understand like your input got converted into the token type IDs, and then with attention IDs. All that happens with tensor. And when we go for next step, which is model forward, we have applied over here with pipe model. And what happens over here, it gives something called as logit. Logit is like where you are converting or you are mapping each of it to have um, some kind of like uh, a a mapping which has to be happened with each of it. So we are having the logic being applied, And then we'll have the post function, which is like your post process where you will be getting the output over here for what is the score that what you are going with. Now, understood so far with what how does the tokenization concept work? Like you will be having the message being added, and from that message you will be passing the pre-process, and you will also have the model being given for it, and from that you will have the tokenization concept being added, and all those ones can be applied, and from that logic you will be given the response out. Like if it's just I'm so fluffy, I'm going to die is an example that what we will get. Now let's see with an example of how does this happen with the value of encoder and decoder. You have Q, K, and B, which will happen over here. Don't get confused at the part which is being over here. It may be at a too high level. So whenever you are giving an input, right, what exactly happens it is you will be applying the you will be applying the normalization method that needs to be added. And once your normalization method that gets added over here, you will be having the normalization that what you had been passed to your model, and that model will be taking care of what it has to perform. Like there are normalization and other things that what it want to happen from that side as well, and then that will be giving the attention being added, and that will be giving you the output response on the same. So what you want to understand as part of the attention value, and there is something called as q. We don't want to understand the entire formula which has been there. We just want to understand what is an attention and what is an value, and QKV is something that we want to understand with. So if we go with what is QKB, it's something like the like when you want when you want the attention and other things, then be added for it, right? Like when you have the um okay let's see an example for that. Like you have which part of the input should I pay attention to right now is something that you are asking it, and how much attention we have to pay is something that you are giving it. Then what exactly that will happen, it is something that where the QKB, which is query key value, will play a major role. Query is something like, let me write it over here so that you understand that. Query is like, what am I looking for? And say in case like if you have the cat sat on the mat, then you have the query of sat on the mat, right? So sat is something that who is who is sitting on it, who is related to that action, what is related to that action, what did it do exactly after sitting is something that you are deciding, right? So that becomes q. So q is like what is the word, what this word wants to know is something that you will be giving as q. And when it comes for K, then the it's something like what do I have? What do I have is something that we will be having it over here. This is kind of like the key that describes what each word offers. Each token says like this is the kind of the information I represent. And the same example that what we have, cat is kind of like key that says I am an animal, likely a subject. Mat is kind of like a key which will say I am an object, location related. I will be on the floor. So K is kind of like the label for each of it. So you will be having we understood about what is Q and K now of the formulas that what we apply. And then we have something like value. For the value to be applied, what information I have to give for it? Considering the same example of cat sat on the mat. Now, cat is an actor of what we want to achieve with. Mat becomes kind of like the one that what we have over here. Like what exactly we are doing in this V is like um, once the model decides which words are important, right? It needs the actual information from them, and that information is called as the value. For that, same example of cat, when you encode that into something like the cat is the actor, from the mat value, you encode it to be like the location information is the matter that what you are getting. So V becomes the content you actually want the word to be taken from. So now did you get the understanding of Q, K and V? This becomes the basic of the attention of how does it work. Let's now see how does the attention work. Attention are something like take the query of the current word and compare the same with the key. First is query and compare the same with the key. And third one is similarity that what you want to similarity that what you want to add with, and then you will be converting that into the softmax that what you are adding it over here. Like you will be converting that into the attention weight that what you have, and combine all these ones as part of the next step into some values, which is the combined values that what you have, and then will give the result as the context aware representation. So your Q ask, K matches, B delivers. That's it. Now, if you don't understand this, right, like let's take something to be of an example for the same. You go to an restaurant and you say to like something you I mean, why do you go there? Because you are craving for something, or you may be hungry, or you want something to be eaten like a sweet or spicy or something of that sort. That's why you are going there. So what you want to do, like eating sweets or having spicy, becomes your query. Then eating something like the description that what we have, like the menu item descriptions with spicy or sweet, or the different varieties that are being part of the hotel's one, right? So that becomes the key. Now, the actual dish that what you receive is the value that what you are getting. That becomes the whole sort of the description that what you are acting with. And once you are, why exactly we need this one when we are an agentic AI is like, you are converting everything into vectors, right? Like if you know vectors are getting converted over here, And that's the reason we are having the encoders and decoders being added. And we also understand about the QKV better. And that's something that which will help you out in giving the response, like what it has to add with and why it has to do the one with various ones that what you wanted to move on, and you will be proceeding with those ones better. Let's understand like why at what situation we will be using the encoder and decoder, and then we'll also be having the key key functionalities that what we have. So the key feature become powerful and efficient, and this is kind of like harder to train decoder with the context that what we have. Also, it's best when we have the context and response are properly separated. And it's not ideal when we don't have the context and response division being added for it. You will be setting the context and you will be getting the output for the same, right? So that's something that your LLM will be so good in doing these things. So that's where we'll be having the relativity of these ones which are there for your case. Now, let's understand about this conversational task. What you can do with the model that what you have, you can either generate some text, or you can have the conversation being generated just like a chatbot that what you have. Your text generation could be like, if you go ahead and ask it to generate some content by typing in just like once upon a time, and it generates the response for you. All the one which it generates can be of text generation, and all the one that what it has with the conversational agent can be of the one with, like, it has to interact with the way that what you are having with, then that becomes the conversational one. Like, it will be giving you the response on the format that what you want to achieve with. Now we know, like, it can do text generation, it can do conversational one and other things. Let us go for next one, which is modular modalities. What does modality mean? We saw in the previous one itself, like modalities are like inputs where you may have different inputs and different outputs which can be got out of it. What is modular modality? It's kind of like whenever you are passing in the text and whenever you are expecting it in the format of audio, or when you expect the image and get the output in the format of like animation, or that could be of anything that what you are expecting it to work on. So modalities are like the inputs that what you are giving it to the model that what you have with. How modalities make a difference in the work that what we are having. It's something like the one which will have your data communicated in different ways. Like, if you want a text to be generated, then you are making the data to be text. If you want an image to be generated, then you are making that to be of image. So your modality plays a major role there, and that's like a narrow one that what you have, and that's the same one where you have the data flow in different distributions, and you have the one that what you have been added, like the data will be having different kind of the ways where it can have with, and your data can be produced and ingested in different ways, like it can be in the format of vision, it can be in the format of audio, it can be in the format of sensor, or it can be in the format of text, it can be in the format of the one that what you are expecting it to be of, like image. So that could be of anything. So it, the image that what you are trying to give, can be of anything, and your data that what you are getting out of the model can also be different. So the modalities makes a difference in that way where it works based on the data that what you give it, and from there you will get the output on. Now let's understand how does the large language hosting platforms be like. Large language hosting platforms are something that you will have a model for sure, which could be of these things, like that could be a text model, a GPT model, or that could be an embedding model, which is like the embed models, like text embedding ADA and other things, right? So you have the embedding models being available. Or you also have the DALI, which is used for image generation model. The image, I mean, the models will be deployed into the server first. And what it happens is, let's go from the start. You are a user. This becomes the user, and your end user application will be having the some kind of prompt which it actually passes on, right? So you will be passing it, and from there it will go for the query that what it want to do, and that touches the model, and then it gives the response. So the whole sort of thing works in this way, like user prompts the query, and that gets passed on to the model, and that model can be different format, and that gives you the response. And how it happens over here, related user is passing the query, and that query gets routed based on the way that what it has, like either the model has to be selected or the completion has to be done. If it's a model, then that will go for the model selection from the server management, and it will be giving you the response. If it's a retriever microservice, then what it would do is it will be either having chat or embeddings or image, like what we saw, and from there it would be getting generated. Like your chat completion model can be there, or embedding model can be there, and other things can be generated. Now let's understand the same of how it happens. All the one that what you have as the query router access, we have this models that whatever we had discussed, like that could be of Olama, or that could be of STXL, or that could be even your GPT, DALI, embedding models. That could be of anything. Now that what you are trying to do is you are trying to add the messages, like whatever the message that what you give to it will then be passed on to the chat completions or the model that what you have, and from there you will get the output, right? And that's something that we know. Now let's see how does the message look like. Say in case if you have some instruction to be passed, then you pass it in the format of the system. If you have some role that needs to be passed, then you will be giving it in the format of like user. So all these ones are kind of like getting passed, and you can add the user for it. Like you will be having the system user and other things, like you will be having the model as mixtral, temperature, toppy, max tokens, stream true, and other things, right? So you will be having everything being added together, and from that it will give you the response with. So whenever you are having some kind of like instruction, then it is like You are adding everything together and you are passing it. Unless and until you don't give the model name, then how does it know on where to act? Or when you don't give the content of what it has to do, like what role it has to work with and what user had given to it, then it doesn't know of what it has to do at all, right? Like what is the user prompt, what is the system instruction, that what it has to do with, it doesn't know. So you will be passing everything as the chat completion, and that chat completion will then be called over here, which is something to be like your instruction. And that instruction will query the model and will give you the output after that. So you will have the output after all these steps performed together. Like you will have the messages being added, you will pass it to the chat completions, and that chat completion will look for the system message and instruction that what it has, and it looks for the query and content that what all it has to look like, and it matches with the model that whatever it want to act with, and it gives you the output of the same. Okay, now we'll see like with an example of how does that work with the endpoint orchestration. You are a user. You want the chatbot to be chatted with. You are giving in some kind of like instruction which are there, and you are giving it to the chatbot on how it want to look like, and you want a very lightweight based orchestration which should happen, and that orchestration can happen with the help of like lang chain, which is being present over here. So the lang chain will have the things like documents gets loaded, text splitters can happen, vector stores are getting stored, your prompts are getting stored, and all the things are happening with the help of like lang chain. Now you have different model completion models, and then chat completion model embeddings and other things. Like you have these many models which are being available. What it want to do, the user will communicate and that communication will get back, where what it would exactly do is it will have the LLM in place, and that LLM will have the system message and the user message, which will decide everything based on your fact. Like if you are giving it, then that becomes the user message. If system is giving it, then that becomes the system message. So that is something that which is happening over the whole chatbot flow, which is happening. Now let's understand the concept of what is generative AI. Generative AI is like the content generation which can happen by the language model. Like it could be it could be of large language model, or it could be of a small language model. When it is a large language model, then you are having huge volume of training data which could be given for it. Also, you have millions of parameters that could be given as part of the large language model. When it is a small language model, then you are giving it few volumes of data to it. Also, the fewer parameters which are being present. And now your generative AI model can have it either in LLM, or that could be a small language model as well. So it could be like your model can be of anything. It could be a LLM, it could be a SLM, but the input to the model, that becomes the model. Now you want to pass the input to the model, which is you are passing in the prompt. You are passing in the prompt over here, and that gets hit with the model prompt model, and you will generate the response. So That is something that the model will be doing. Input gets passed, output will be generated. How does that happen? With the model that what we have. The output can be of anything, which could be in natural language or image or code or could be of anything. We saw something as a new word now, which is called as prompt. What is a prompt in generative AI session? It's something like you have different things which are system prompt, user prompt, completion, history. Okay. Now let's go each one of it. System prompt. System prompt are something that which will be having as system messages, which will actually define what exactly your system has to do with. You want your AI assistant to be act as a professor. You want a AI assistant to be act as a document writer. You want a AI assistant to act as your doctor. Then that becomes the system prompt. You are an AI assistant where you are giving in the instruction, and for that instruction, you will be having the model behavior and other things being added, and you will be giving the instructions for the same. That becomes the system prompt. Now, let's go with user prompt of what it is. Now, you go and ask the model, like, I have this assignment and I have doubts on it. How does that do? So, it's like a professor now, right? So, it should be answering you in a way that the professor does. You should be doing these things and it should be doing the one that what is being present, or we wanted it to act as a doctor. So you are going and telling something to be like a, I have a fever, I have fever now, and I want medicines for the same. But not exactly don't do those. And that's not recommended way of using your chat GPT or your models to be your doctor. I'm just telling you as an example. So when you go and ask it to be of what your um, what your fever medicine is, then it will be giving the response on the same, right? What exactly you are giving it? I have fever and I want medicine. That becomes user prompt. And completion is something that the response that gives you back. Dolo 650 is when you have Dolo 650 for 2 days, then your fever should be gone. Or even if it's passes, then visit a doctor nearby is something that your AI assistant should be giving you as an response with. It could be of a different reason, like dengue, or it could be of a chikungunya, or it could be of a chicken pox, something of that sort, which comes all with the fever diseases that what we have. So whenever that gives you the response in this format, then you have the completions or response from the model, right? Like the Tolo 650 for 2 days and try for it. And then in worst case, you should go for a doctor. That is called as the response that what we get. Now, history. I don't want to go for a doctor. I just want to continue with the medication that what I have that you have prescribed is something that you are communicating with it, and it stops. I like it will answer for you, and that will be kind of like taking some examples on the one that what you are trying to give it, right? So all that what the user has did for the past will now be converted, and that becomes the history. You are passing the history as well in each iteration, and based on the history you will be giving the output on. For that you will be having the history as well being added. So you will have the history being defined for you and will be giving the output on the same. We understood about the generative AI. How does it happen? How does it work? How does it all do? And other things. We'll understand how AI works in generative AI works in AI Foundry. What exactly AI Foundry is? You may ask me, like, what exactly AI Foundry is? Why do we need AI Foundry? AI Foundry is kind of like a hub of services where all the AI related things will be kind of like given over there. Like you will be having the models, you can test it out, you can have the deployment being done there, and then you can have the prompt flow being added, and then you can connect your storage and key vault being connected when you are doing that with the services, or when you want to integrate it with image or text or some kind of like services that what you want to do on, like you want to translate or do anything that what you are about to do, then your AI Foundry will be helping you in providing the services for the same. There could be of two types your AI Foundry will be helping you with, where you can get your project being created. One is AI Foundry project, or it could be a hub-based project. So, what exactly is AI Foundry project? AI Foundry project is something like where you can go ahead and create the AI Foundry AI Foundry resource alone, and with that resource, you will be having the hub. With that resource, you may have the resources being added, and from there, it will be allowing you an option of using all the services that what all you have. And that's something that the AI Foundry will allow you to do. Now, let's go for AI Hub based project. This is something that independent when it comes for AI Foundry project. AI Foundry project. Now, hub. Hub is something like your hub where it will be having everything together. It allows you to have everything under it. So it will, whenever you are creating a hub, right, what will happen is it gets key vault and storage being added to it for sure. And along with that, it also allows you to have some kind of like some kind of like thing like prompt flow, compute services being connected to it. Prompt flow will be available when you are opening the hub based project, but the same will not be kind of like available inside the AI Foundry related projects. Also, when you want to when you want to do some customization or rack or anything, then you will be having the hub based projects being selected more, like you will be doing that more instead of the normal Foundry based project. Okay, now let's understand about what is the Azure AI Foundry, and then we'll come back over here. For For a Foundry, first we will log in inside the portal.azure.com. For this lab, we will be ensuring that we'll be logging in inside the incognito such that your um your regular credentials of your office account is not getting clashed with your one that what we are about to do. But for now, I had used it over here. So first step that what we want to do is we want to create a Foundry resource. For a Foundry resource to be created, you will search for the Foundry over here at the top, and you will be having the Foundry resource which has been there, and you can select that, and it will be opening up the different ones which are being there. Now you have the Foundry resource which are available to it. Like you have the Foundry Hub, and then you have Azure OpenAI, Azure Search. These are along with the Foundry, you have these. Apart from that, if you want to connect it with different services like either your automation or computer or vision, face API or health insights, or that could be even your speech translator, anything which are been available under the more services can be used. Or if you want to connect the classic AI services as well, like anomaly detector or language understanding or metrics advisor or just the Q&A, those will be kind of like deprecated now. Like up after the March 25, it is kind of like retired last year itself. So many of the ones which are kind of like here are deprecated, and you may have the ones which are over here as the new one. Once you have the Foundry resource, you will, I already have two different Foundry resource over here. For creating a Foundry resource, you will be clicking on create and will be adding in the resource group which has been listed, and then we'll be giving it a name for what we have, and then we'll be selecting the region as a different name, like project 1, project 2, or like the name that whatever you want to give it. And then what it would do is you will be selecting the region on where you want to deploy, like whether it's a central India, or whether it's a East US, or whether it's a Spain, or whether it's a West US. So you have different data. Uh, you have different data centers which are being available, and for now we will be using the specified region that what we have, which has been like either that could be of France or that could be of, just because our quota is limited within that region, or we may have the data centers which may also have been kind of like down at times. So we are using this specified region. Once we have that, we'll be having our first project, which is like the project over here, and we'll have the content being ready for that. With like content ready review policy being added, this also can be changed. Like if you want to change the name of all of it, then you can go ahead and change it. One recommendation that what you have is please don't maintain multiple foundries unless and until you don't want that to be added. Like I am for now keeping both of those things alone, and we are getting started. Now we have something called as test foundry, which is T foundry over here, and we will be navigating to the one that what is being present. When you click on that, right, to go to the foundry, you will have to go to the foundry portal. To make use of foundry, you should navigate to the foundry portal. So you will be clicking on the resource that what we have created. And once you have once you have did that, right, you will have different options which are like right from how do you give access to it, and how do you manage all these ones, like key and end point, all the one will get created, like where it is being done, whether it's a open AI or whether it's a services that what you have, all the one that what you have will be created under the key and endpoint, and will also show you of where we can find it inside the portal as well. Now we'll go to the Foundry portal. Now we'll go to the Foundry portal, navigating to the Foundry portal now. So we are into the Foundry portal now. Did you observe? You also have the URL keys over here. When you log in itself, that key and this key, which is being present over here, will be the same one that what you are trying to use. When you open the one that what is being present inside this, like how your API key has to be added, like Foundry, OpenAI, and AI resources, all will have the same key been added. One first point, all will have the same key which are being present. Whenever you want to use this API, right, you will go ahead and use that. Or maybe let's start with the differences of why do we have three different URLs first. Three different URLs are there because you want the Foundry resource, like uh, services based out of it. Like you want the whole project to be accessed, then you will be going with Foundry resource. Whenever you want to access the model that what you have created inside the Foundry, then you will be going with OpenAI. Then whenever you have something like AI services, which is like when you have the when you have things like AI search, or when you have things like AI related services which can be of text to speech or speech to text, then you will be having the AI services being added over there. So that's the reason we have three different URLs which are being available. And you have three URLs, but your key will be kind of like same. And project details. This project detail that what you find here and the project detail that what you find over here will be same, unless and until you are working in the same project. This is like a overall view, and you can also find it over here of what MSDN subscription that what you have. And if you want to have the subscription being changed, then you will be changing it. Or if you want the directory to be changed, then you can change it over here. Or if you want to change the project that what you have created. I have two different projects and in two different Foundry resource that what we have created, and both of it has the project default as its project name. So we have two different project default which are being listed. So where your location is being posted is something that your description will be giving on. And if you want to switch between it, then if you change that, then you have the option of switching, right? So you can switch and you can work. Unless and until you have the access for different projects which are being created, then you can go ahead and use the one that what you have. Like you will be having the details that are being needed, and you can use that. Now we understood about overview. Now how about the model that what you want to deploy? First thing that what you want to do is like you want to have the model being deployed, right? For that, what you will do, you will have model catalog is something that which will be helping you out in understanding about each module, each model which has been there. Either if you want to build a custom AI model, or if you want to build a you already available model, like fine tuning model, that what you want to build, anything that what your requirement can be of, right? In those situation, what you will exactly do is like you will be having the models being deployed over here. Like you will have the options of having things like you will be latest announced model, and then which model plays a major role, and then you will have the compare models option which are being listed. Like this is where you can add the model compared for, and you can have the price of how does it work, how does that work for lower cost and higher accuracy. All these things can be changed over here and can be checked. So this is your model catalog, and you can have different models which are being present as well. There are n number of models, about like 2000 models which are being present inside the Azure, and you can go ahead and use it. Now let's understand the left pane that what we have first. So let's go to test. Okay, let's not come to that part. Let's come down. We understood about what is model catalog and how does that work. Also the overview of how does that work, right? Now let's come to this part. Like you want to deploy a model. Where exactly you will go? It will be under your asset, because you are creating a model for your own project. That becomes your asset of where you are creating it. And you will be deploying a model. You will first deploy it from the base model, and either you can select it with different GPT models, which is like GPT 4o. Yeah, when you see over here, you have GPT-4o, right? So you will be selecting on that, and you can create on click, and you will have an option of deploying the GPT model. This is the deployment name that what we have. If you observe, we already have a GPT-4o, and that's why you have the GPT-4 4o mini as the same one. So you will have to give a unique name for each of your deployment which has been there. You can deploy the model of n number of times, but make sure you are giving it a deployment name to be unique. And next comes for deployment type. Where do you want to deploy? Either it has to be in global standard, or either it has to be in data zone standard. Data zone is like how does your data zone works, right? So in that standard or normal standard, or it works with the regional wise standard and other things. The best practice is always to keep in global standard. Whenever you are creating a standard, you will be creating it in the format of global standard, and will be creating that in the global standard, and you have the customize option over here. So when you click on customize, you will have other options which are available, like whether your model has to upgrade once your default model becomes available, or what if your model goes away and you are using it in your production, and if you want to change your model, then it will be like model upgrade has to happen, and that should not affect your productivity that what you have, right? So that's why we have this option when to update, of where to add, where when it is deprecated. like when it is about to deprecate, like you will be having opt out of automatic model upgrade, where you are the person who is responsible of upgrading it. Or if you have the current version expires, then you will be upgrading it. Or if you have the new version becomes available, you will be you will be using that. Default option will always be like your whenever your default version being available, it should be used. And then where you want to deploy the version with, where exactly you want to deploy the version, and then what which AI resource that what you want to connect with. How did we navigate here? From the foundry with the help of the AI resource, right? From the foundry, we created a resource and we are connecting the same resource that what we had connected over here. And always make sure your token per minute rate limit is reduced as much as possible. It should be not more than 55K or 10K, so that it does not give you a big answers that what you are getting. And you can save the token and you can have the option being added. It is not allowing me to save it because it does not allow, I mean, it does not have the option of having the same unique name. Once you have created the model, you will now have this as your deployment name, and then you have the option of testing that out inside the playground we saw over here. So you have the option of testing that out in the playground, and then you have metrics, risk and safety, where you will have which content filter is being applied. We will come back to all those ones in a while. In a while. So when you have deployed the project, right, what exactly it would do is it will be having the endpoint being added, like the target URL will be added, which is the one that is being present over here. Along with that, you will also have the key being associated with it. What exactly this key is? So you will be having the key, which is like what it does. So what it does, it will be having the deployments, which is okay. Let's now understand why your why your model is kind of like having different URL name that what is being there. If you go over here, you have AI OpenAI option, right? So that OpenAI option, that what you have, like the foundry.openai.com. Note it down somewhere or note it down in your mind for a minute. Now let's get back to the model and endpoints. Now come back over here. You have something called as cognitive.services.azure.com. Now, you may get confusion for sure whether I should be using this or whether I should be using that. You told me like whenever we use the um, we use the model, then we'll be going for that and not for this, is something that you had told me is something that which may start popping up on your mind. But wait, I will answer you for the question. Go back over here, see for the services, what is being available. You have cognitive service, which is available over there. So cognitiveservice.azure.com. And now coming back, cognitiveservices.azure.com. Your first part is done. You are getting the services from the service AI search one. And then what exactly next step we are doing is, since it is a OpenAI, we are using the OpenAI as the model and then deployment. And then we have the deployment name. It's a chat model. So we have chat slash completions over there. If it's an image, we might have got images slash completions. I will also deploy a image model. I will also deploy a embedding model and will show you how different it is. So whenever you are deploying different models, right, your image, your URLs get different. And it's not the same URL that what you would be adding as well. Like if you have the whole URL, then fine. Else you would be combining it and you should be like storing it somewhere either in key vault, and from the key vault you should be adding those into your code, and from there you have to fetch that, right? In those situation, understanding about what does that URL has works. So this until azure.com becomes your base one. After that, your deployments of what it has, your deployment name of GPT-4o mini, since it's a chat slash completions, your API version of what API version that what you have. All that you have over here. GPT version, API version will also be listed over here. Um, API version, API version, API version. Okay. Anyway, when you want to access the resource, right? So you will be having the API version and other things being added. And next step that what you want to do, either you will be using it here itself by training it, or you will be connecting it with your code, right? To connect with your code, you want to know the procedure of how does it work. So you have different options which are like Python, JavaScript, REST, C sharp of it gives the it gives the something like a basic part of how do you connect it, which which is exactly for Azure OpenAI SDK, or if it's for Azure AI Inference SDK, how does that work? Is all something that which is being added over here. How is the key, if it's a key and key authentication, or if it's a Entra ID authentication, how does your code look like? Is all as a template which has been available over here. First step, what you will do is you will be having the client being established, which is Azure OpenAI being added. And with that Azure OpenAI being added, you will have the basic sample code. If you see, you are giving the endpoint first, model name, deployment name, everything. Your model and deployment name are same because you didn't change at the start. Your model name is also the same. So we are giving it over here. And your subscription key has to be given. Your API key, your API version is kind of like same for now, which is 0124 12. You can use it. And how do you establish a connection is like you will be having the Azure OpenAI being added, and from there you will have the endpoints being selected and the API key which will be having over there. Once you have that, you will be something called as chats.completions.create. You are establishing the connection between the OpenAI in the first step with the client. Now your client has initialized. You want to get the response for the same that what you wanted to do right now. You will be instructing the model of what it has to do. For that, it will be having something like messages, which is like you will have the messages will always be in this format. Message will start from here and message will start and end until here. These are like the examples. This could be an example that what you give. This could be a only one thing that what you give over here, and we have separate things on how do we how do we exactly give the prompts as well, which we will cover later. Like we have zero shot learning, we have few shot learning, we have chain of thought, all those ones being added, and we will be adding all these ones together where it messages will be in this format where you will pass the message. First understand the part of role. Everything will be in different roles. So from this part to this part becomes one role. This part to this part becomes one role. So first role is system. Second role is user. Everything that what you write will be in the format of braces to braces separated by comma, braces to braces separated by comma, and then at last you will be closing it by square braces. When you close the square braces, then your message is done. Your messages that what you are trying to pass to the prompt will get done over that. For a chat completion model, what you want is you want the maximum token to be passed, temperature to be passed, and then top P, top K, and all those ones to be passed. Model deployment. We will understand what are these parameters in a while we are seeing that inside the playground, right? Why we need to pass this is something that we will understand so that you will get to know. But for now, these are the instructions that what you are giving it. Role user becomes the user prompt that what you are giving it. I am going to Paris. What should I see is something that when you ask it to a chatbot, the role of the system is something like the helpful assistant. It should be helping you with either either the places where you can visit and other things. So the first response that what you are trying to get is being printed over here with response dot choices dot messages dot content, and we are giving it from there. Once we have got that, this is another example where you are turning the multiple conversation, and this is where I told you like you can have multiple messages or multiple role being added, where this to this becomes one role and this to this becomes one role, right? You are passing in assistant, you are passing in two user as example, you are passing in one system, sorry, one system, one user, one assistant, two user and one assistant. So two user becomes few short learning because it goes more than one example that what you are trying to add, and you are giving it an example of where and how it want to act with. Assistant is basically like your way of how you want to proceed with. Like the examples are always being given inside the assistant. And your system will always have the instruction of what it want to do. User will always have the instruction of what it has to proceed with, like the prompt that what you are trying to give. So these are getting passed over here. If you want to stream, we will see all these in our later labs, but just understand for now. Like these are the ones that is being present, and you have the sample codes as well being present. Now let's get back. So for now, we saw like we have created a model and we want to test it out. So we'll go for the testing over here. And for the testing, you have the instruction which is being there. From the example that what we saw, this becomes the system, right? When we pass it via the Python code, you are a AI assistant, helpful AI assistant is something that we saw. So this becomes the system message that what you want to do. If you are confused whether it's a system message or something, at down, you have something called as generate system prompt. You can type in your own prompt over here, like in the natural language, that will be creating it in the exact format of what the model expects. First step is done, and then there are different parameters. We also saw different parameters which are being part of the which are being part of the one that what we have, which is like you have past message. Past message means how many messages at the past have to be added. Maximum response to be of how much token that what it has to get with. It could be just a 1,200 or 3,000 maximum response that what it can achieve. Temperature and top P are for randomness. Temperature is like when you set that to 1, then it means that your temperature will act so creative. Top P and temperature should not be set to always kind of like together to 1 or more than 1. Top P can be changed and set until 1, as goes with temperature as well. When you change top P, don't change top temperature. Top P, if you had seen earlier or if you had worked earlier, about a year back, I would say, you had something called as top K as well being associated, where top K is for finding the number of records that what it want to take. Top P is for probability that what it want to do with. And the temperature is for the randomness that what it want to generate on. And then it will be setting the values based on that format and it will be getting generated. So stop sequence is like an array where when you give that format of what it has to stop with, like say the user says buy, and if you receive that buy, you should be stopping to send them messages anymore. You should not be again and again sending it message. And your chat gets disabled by that way. That becomes stop sequence. And then frequency penalty. Frequency penalty is like when you have the penalty being applied, like how frequent is your word inside the token, then you will be applying it. That varies from 0 to 2. Again, the presence penalty is also the same, where it varies from 0 to 2. And when it's similar like temperature and top P, where you will be having the option of having having the like frequency penalty being applied, like you will have the frequency by the word means like how frequent is your word happening, right? Presence is here like your how is your word present. Similarly, you will get the response on the same. You will apply frequency penalty and presence penalty. Whenever you reduce it, it means that your words are getting not repeated, and that's not getting um, too often been repetitive. When you increase it to high, it is a diverse one. You may get whatever you wanted to do on. And when you want to set it within the context, it should be of low. This is all something that about the AI Foundry. Also, we want to understand about agents, templates. Agents are the places where you will be able to create agents. We saw about for now from the start overview, model, catalog, playground. Agents is like where you will create multiple agents or single agent based on your requirement. Templates are something like where you will be using your template, like the GitHub options will be available, and from that GitHub options, you can go ahead and use that. And next becomes the fine tuning. Fine tuning is like when you set your base model, from that base model, you will be having the um, generations, like customizing your own model based on the behavior that what you have, right? So you will be doing that with the help of the fine tuning. Content understanding. Content understanding is not supported under this region, but it's something like which when we want to have the content understanding being added, like when you want to understand some content, then it goes with content understanding. You have tracing where you will be tracing out from where to where it went off. Like this is where when your error flows in, then you will be debugging it inside the tracing. Monitoring is where when your consumption is kind of like going high, or when you want to monitor something, what's going wrong or what's going right will be monitored under the monitoring. And then evaluation. Evaluation is like when you want to do testing purpose for the unknown data set, then you will be going and testing it with your evaluation over here. Yeah, you will be going and doing it with evaluation over here. And then guardrails. Guardrails are like when you have the content filtration being applied. Like your data will be marked into four different categories basically. Like by default, your content will always be like segregated. When you click on next, you have four different options: violence, hate, sexual, harm, and then prompt shield. Prompt shield for indirect attacks. We'll be covering this on a separate day. Don't worry. But for now, you will be applying a content filter for all of your model that what you have, and you will be you will be setting that whether it should allow or not to the one that what you are passing with. That's enough for now. Just have that understanding, and that is being done with guardrails and controls. Risk monitoring is something that which can be done with the help of your risk monitoring. And then like where do you want to have the risk and alert being enabled will be happening in risk. Governance is like when you want to connect it with intra, or when you want to connect it with side dot integration, some kind of like integration where you want to perform. And then last comes with stored completion and batch jobs. These are Azure OpenAI's related itself, where you will be having the Azure OpenAI option being enabled, and from there you will have the Azure OpenAI option being like if you are having the Azure OpenAI, right, you will have this Azure OpenAI being added, and from here you can go ahead and use it. And at last, you have batch jobs. At what batch job it should process is something that you will be having. Like when you click on it, when you upload the file, Then you will have the option of at what batch it should be executing. Is all something that your batch job will be having. And this is something that we saw, like indexes and data, where I mean model and endpoints is something that we saw. Data and index is something like whenever you are uploading some kind of like data inside your playground or something, or if you are uploading it via your this itself, like these are available when you go for Azure OpenAI. Like when you create the Azure OpenAI and when you create the hub and go for data and indexes, then you will be using all these ones, and from there you can have the data that what all you need can be added over this particular path. Else, the one which are available alone will be getting listed over here. That's it for an overview of what is Azure Foundry. Now, we'll see, like if you want to understand the quota of how does that happen, you will come to the management center which has been available. We'll be checking for all the resources that what is available under your name. And if you want to manage the resource, then you will be coming over here and will be kind of like if you want to delete it, then you can go ahead and delete it. And now you just have one resource, right? So you can delete it whenever you don't want that resource, or you want to add resource, then you can add it. Or if you want to add some user for this account, then you can go ahead and add the user. Or if you want to add some connection to this connection, what I mean over here is like if you want to connect some kind of like data bricks, or if you want to add the SharePoint or storage or serverless model, everything, right, which are available to it, then you will be having the connection being established. And then you will have the overview of what it has. And now quota plays a major role for your model that what you had deployed. You should understand about the quota, right? For that, you will be coming to the quota and you will select your subscription that what you have created, and how much is your available quota and how much is your assigned quota that what you have. Available quota is somewhere around 3000 for me now. So it is showing for standard or global batch or these things. And when your quota is being kind of like deployed, then you will be seeing that by different region and other things which are being there. I hope you had an understanding about Azure Foundry. Now let's go back to the Azure Foundry portal. I like the theory part. Now, can you answer like what is Azure Foundry now? It can be like a create and manage hub that what you can do, integrate the services, deploy the models, test a model inside the interactive playground and other things, right? So it can have different things being added. All that which has been listed inside the theory is something that we saw for now. Are we good with the session so far? And you can answer for these. Okay, this is also something that we saw, like we will have the model catalog. Model catalog is like will be helping you out in choosing the model catalogs, and how does the model catalog will be helping you in having the selections that can have. And then you can have the benchmarks across the model, like you can compare those. And when you have the deployment option where you have like you have you have the different deployment options. Either you want to do the standard deployment, which is like the Foundry models, or the Foundry models goes with serverless billing. That is something in preview now. So that is still possible. You can go with a serverless compute or managed compute, and that works in this way. And how do you optimize a model performance is like whenever whenever you are using a prompt engineering and when you want to go ahead and do the performance being added, then you will be optimizing it of what, like, how, when your prompt is so good, your output will also be kind of like so good. Keep that in mind forever. So for that prompt to be good, of what it has to do, where exactly it should look for, and how the exactly look for strategies will be happening, you will be plotting that, and your model optimization will be good when it comes for just up, like, in this way. And then you can apply the logic on the same. Yeah, we had deployed what is Foundry SDK, and then we saw like what are the various connections which can be done. How do we create the client inside the client is all something that we saw. With that, our theory part for today gets over. Okay, so we'll be setting up the lab as well, where you have to set up the PMs and other things, which we will do.
Sivaita.